Okay, great. Are everybody able to hear me? Okay, great. Thank you so much for joining this webinar, which is the third in the series on smokeless tobacco control. And today, the topic that we are going to be dealing with is the scientific basis of regulation of smokeless tobacco. We have two very eminent experts who are going to be speaking today. And the first is Dr. Mark Parascandola, who's a PhD and an MPH. He's an epidemiologist and working in the area of tobacco control over the last many years at the Division of Cancer Control and Population Science in the National Cancer Institute in the US. He received his doctorate in philosophy of science from Cambridge University and his master's in public health from the Johns Hopkins University School of Hygiene and Public Health. Mark also completed an NCI Cancer Prevention Fellowship and has authored numerous published articles on tobacco use, prevention, control policies, as well as epidemiology research methods. He served as an editor for the NCI WHO report on the economics of tobacco control, as well as the NCI CDC report on smokeless tobacco and public health. He has worked on a two-piece encyclopedia on tobacco, its history and culture, and served as a member of the IARC working group on the methods of evaluating tobacco control policies in 2007. He's a program director at NCI, and he currently oversees a research portfolio with focus on global tobacco control, smokeless tobacco use, and implementation science. He has served as an Embassy Science Fellow and expert advisor on tobacco control and air pollution at the US embassies in China and Poland. Our second speaker is Dr. Ghazi Zaatari. He is an Associate Dean for Faculty Affairs, Professor and Chair of the Department of Pathology and Lab Medicine, and Department of Experimental Pathology in Immunology and Microbiology at the Faculty of Medicine at the American University of Beirut and Lebanon. He is also in charge of the Environmental Core Laboratory and Director of the American University of Beirut, Chair of the WHO Study Group on Tobacco Product Regulation, TOBREG. He is the Executive Committee member of the Tobacco Laboratory Network, which is the TOB LabNet, and he is the Vice President for Asia for the IAP, or the International Academy of Pathology, member of the Education Committee, President of the Arab Board of Pathology, and Secretary of the Arab Division of the IAP. He's a member of many other regional and international pathology societies and contributed to the publication of several WHO reports and on number of tobacco products and regulation. He also heads the smokeless, the Hubble Bubble or the smoking pipes division and the global hub on the hookah in Lebanon. So today's seminar is basically going to be focused on regulation of smokeless tobacco and what is the scientific basis and the problems that are associated with smokeless tobacco. So may I please request the first speaker, Dr. Mark Parascandola, to give his talk, and it'll be followed by Dr. Ghazi Zaatari, and then the floor will be open to questions and answers. So Dr. Mark, would you like to, I know it's early morning there in Washington, DC, so I hope you're bright as a spark. So over to you, Mark.
Okay, thank you. Well, I'm glad to join you all. So good day, everyone. Well, anyway, I just want to say hello in person, but I'll start to share my screen now so you can see my slides. I'm going to speak first about sort of monitoring the various product types and characteristics for smokeless tobacco products globally, which is, I think, one of the big challenges we have, many different types of products out there. And so how do we go about trying to monitor them and understand their characteristics, and then even regulate those products, which presents many challenges. First of all, I wanted to point out that we did put out a global report on smokeless tobacco and public health. Some of you may be familiar with this already. A few years ago, there's already a lot of new research that has come out since this report was done, and there's also now an India-specific report as well. But some of the information I'm drawing on is in this report, and I think there's still a lot of very useful information there for understanding smokeless tobacco use on a global scale. First of all, I think it's important to have a definition of what we mean by smokeless tobacco. This is especially important when talking about regulation of the product, because in a regulatory setting, it is critical to have a very clear definition of what is the product that's being regulated, so this is this is an important first step. So we do include in that report a sort of definition of what we mean by smokeless tobacco, but within that category, there are still many very different types of products that fit into this definition. And just to give you some examples, I'm sure you're familiar with some of these products, but there are a wide variety of different types of smokeless tobacco products in use worldwide. And this slide shows some of the locally produced products, so often used in a relatively unprocessed or powdered form. And they may vary widely depending on, the local context. And then we also see a range of new kind of mass-produced products being sold around the world, including the snus, smokeless tobacco in pouches, products with different kinds of flavorings added, different kinds of formulations, even products that appear sort of like a pill but contain tobacco in them. So the market is continuing to innovate too, and this presents new challenges as well. So we divided smokeless tobacco products into kind of three major categories. First of all, separating the pre-made products from the custom-made products. So the pre-made products included both large-scale manufactured products, like the snus products that I showed, and then also locally produced cottage industry products that are still produced in a facility of some kind, but on a smaller local scale. And then we also have the custom-made products, which are prepared by an individual vendor or an individual tobacco user according to their taste. So they may mix it up with different flavorings, different additives, depending on the user. So, there's kind of different levels of variation across these categories. So the manufactured products tend to be more consistent, throughout, where the custom-made products tend to be very individual to the user. We also divided products into different categories by ingredients. So, of course, since we're talking about tobacco products, the first ingredient is tobacco, but the tobacco itself can, there are different forms of the tobacco plant. There are different ways that the plant is processed, the raw tobacco is processed and prepared for use. So there are a variety of different types of tobacco that are used. And then added to the tobacco, we have various other kinds of ingredients, including flavoring ingredients, other plant materials that are used along with the tobacco. The alkaline agents here are very important. Products like slake lime that are often added to tobacco because they will boost the nicotine delivery to the user. And then we have other products like areca nut, which are sometimes used in combination with smokeless, with tobacco, and are also themselves, carcinogenic. And just some examples of here's from the Ciro region of the custom-made products made by local vendors, and then the cottage industry and commercial products. So I did want to also make a point about the use of betel quid, and particularly the use of areca nut as an ingredient. So this is an area I think that hasn't been explored much. At NCI, we organized a workshop on betel quid and areca nut. We've been working with the Knowledge Hub and with other partners to try and sort of increase knowledge in this area. This table here shows the variety of different types of products that include areca nut. Sometimes with tobacco, but sometimes without tobacco. And so I think this presents another challenge here, because as we're talking about regulation of tobacco products under the Framework Convention for Tobacco Control, the Framework Convention really is by definition, is technically, limited to tobacco. But we know that areca nut itself is also harmful and also dependence producing. And so it has some of the same, presents some of the same health hazards that tobacco does in terms of increased risk of oral cancer among users and this sort of thing. But we haven't, I think it's still a kind of unexplored area yet as to how do we tackle regulating products like areca nut outside the context of their use with tobacco. So that's just something to be aware of as well. So there are many characteristics of smokeless tobacco products that can influence their toxicity, their adverse health effects on the user. So I mentioned already there are different types of tobacco that are used. Depending on the type of tobacco, the levels of various constituents may vary within the tobacco itself. The level of nicotine may vary in the tobacco itself. And tobacco may even be cultivated in a way to enhance particular characteristics. And then after, after the tobacco is harvested, it's usually processed in some way. So, for example, tobacco may be fire cured, which that process, the fire curing, causes chemical changes in the tobacco leaf, influences the level of polycyclic aromatic hydrocarbons and other known carcinogens. So, for example, the PAHs tend to be higher in fire-cured tobacco than in air-cured tobacco. So we know that these different ways of processing the tobacco can influence the characteristics of the product itself, and that has relevance for its, its health impact. Tobacco fermentation also produces chemical changes in the tobacco. So we know that nitrate in fire-cured tobacco is converted to nitrite, which then in reaction with the alkaloids in the tobacco produces what are known as the tobacco-specific nitrosamines. So these are chemicals that are known cancer-causing agents that appear or develop in the tobacco product. And we know that, there are a variety of additives that are used with tobacco that may also have their own property, either harmful properties or may influence delivery of specific constituents in the tobacco. So as I already mentioned, the alkaline modifying agents that influence nicotine delivery. And so there has been some work done to try and assess, well, looking across different products, what do we know about the levels of different ingredients and different constituents in those products? So this chart just shows variations in pH levels and free nicotine delivery across different types of products. So the point here really is to not to focus on any one of these particular products, but just to show you that across the different products shown here, there's a wide variation in the percent of nicotine that is present in the product as free nicotine, and that's the nicotine that's more easily delivered to the user. So you can see even within certain categories of products, like within the Kine product, sort of towards the left side, within the moist snuff at the far right side, there's a wide variation in free nicotine delivery across different products in that category. So it's hard to make generalizations about a particular type of tobacco as to what the nicotine content is, how much the user will get, because there's such wide variation even within a single product category. I already mentioned the tobacco-specific nitrosamines, so we know these vary widely across across products. They're also commonly considered, one of the most potent carcinogens in tobacco products. So in terms of looking at potential health hazard, these are especially important. And we see across different types of products wide variation in levels of tobacco-specific nitrosamines. In this case, you can see in different gutka-type products, or I guess this is comparing gutka to tumbak. Tumbak is a product used in African countries. According to a particular sample of gutka to a particular sample of tumbak, we saw almost 1,000-fold variation in levels of total tobacco-specific nitrosamines. So enormous variation across different products used in different regions. We also see, there have been some studies looking at measures of nitrosamine exposure in users. So this shows total NNAL, which is a metabolite of one of the tobacco-specific nitrosamines. So this is a way of trying to understand what level of exposure is the user getting to these cancer-causing constituents in the tobacco. And it shows that within the user, we see a wide variation in levels of tobacco-specific nitrosamine exposure across these different product categories. So that suggests that these differences in the products do have relevance for understanding the impact on the user. So the challenge is, how do we get a handle on all this variation across these different products? I was just going to give a couple examples here of projects we've done recently, in particular in collaboration with a group at University of Minnesota, which has a lot of expertise in laboratory study of tobacco products. And we see that, we did a sort of pilot effort in the US to try and see, can we actually monitor levels of the tobacco-specific nitrosamines and nicotine as well in a couple of products that are widely available on the market. These were the Marlboro and Camel snus products manufactured by major cigarette manufacturers that were trying to break into the smokeless tobacco market. We collected over 200 samples from 6 different regions of the country, and then looked at the levels of nicotine and the levels of tobacco-specific nitrosamines. And this first slide, you can see the diagram on the right shows the nicotine measurements. There's some variation across different regions. We did see actually change over time as well. And then this next slide shows the levels of tobacco-specific nitrosamines, which also varied. And I think what's interesting here is this is a mass-produced product produced by a major cigarette manufacturer that presumably has the capacity and the resources to produce a very consistent product if they want to. But even this product we saw varied significantly in different regions of the country. So I think that speaks to the challenge of trying to understand these products and then to eventually to regulate them. We did a similar sort of pilot test looking at samples of tobacco products from 3 different markets in Mumbai, trying to use a standardized protocol for selecting them. We had 39 samples from 8 different varieties of manufactured and vendor-made smokeless tobacco products. And again, across these products, we saw enormous variation in nicotine levels and TSNA content. And even the same product varied widely from one vendor to another as well. And you can see in the chart on the right, enormous variation across these different types of products. And so I just finally, we did a similar study looking at areca nut containing products, sort of to try and address the issue I was mentioning earlier around understanding, betel quid and areca nut use, both with and without tobacco. So this study was looking specifically at different forms of areca nut, some processed, some unprocessed. And we were looking particularly at the levels of specific alkaloids in the product, and the alkaloids are important for understanding sort of the biological activity of the product. And again, what we found was substantial variation across different areca nut containing products in terms of the levels of, we were looking at 4 major alkaloids that appear in areca nut. And we saw a lot of variation in the relative levels of those different alkaloids. So again, even when we're talking about areca nut, it's not a single product. There's a lot of variation within across these different products that are containing areca nut. So finally, I just wanted to make the point that we still have a lot to learn, I think, around monitoring smokeless tobacco products. There's still a lot we don't know about, particularly the locally made products used in different parts of the world, how they vary, what their constituents and ingredients are. But we do know, and then also the next challenge is to figure out, even if we understand the characteristics of the products and how they change, what does that mean for health? And this is an area I think we're still trying to understand. But I did want to point out that we do have, now epidemiologic studies from various parts of the world in smokeless tobacco users. And we do see actually variation in the relative risk for oral cancer, for example, in smokeless tobacco users in different parts of the world. So this, if you look at the top of this chart, under oral cancer, you can see the relative risk varies from relative risk of almost 1 in Scandinavia for Swedish snus to a relative risk of 5 in India. So substantial variation in the oral cancer risks associated with product use, and we suspect that these differences may be, driven in part by differences in these product characteristics, by levels of tobacco-specific nitrosamines and other cancer-causing ingredients. And this, in turn, means there's a substantial variation in the burden of disease attributable to smokeless tobacco products. So just to close, I would say smokeless tobacco products should not be viewed as a single product category. There are really many different types of products, different compositions, and even potentially different health effects. And because of these widely varying characteristics, they're in different patterns of use as well. These products are likely to vary across regions in their abuse liability, in their toxicity, and in their impact on health. And so this also presents further challenges, I think, for product regulation. So I'll stop there, but I'll turn it over to Professor Zaatari, who I believe is going to talk about efforts to regulate smokeless tobacco products. So thank you.
Thank you, Dr. Mark. I'll request Dr. Zaatari to follow up, and then we can have questions. In the meantime, I would request participants to send in their questions to chat, so for Dr. Mark, so that we can have a quick response at the end.
Dr. Zaatari, over to you.
Yeah, I'll really just... Okay, first I'd like to thank Ravi for the kind introduction and for the Knowledge Hub on Smokeless Tobacco for arranging this webinar series. I think they're very useful for the purpose that we need to talk about. In addition, I'd like to thank Mark for the introduction. This will make my task a bit easier, but I will walk you through the difficult subject of regulation. It's already known that smokeless tobacco comes in different forms and shapes, and this has been nicely introduced by Mark. And this poses a challenge for regulation. And as has been nicely noted, these products are heterogeneous, so consequently they differ in their contents and emission, and reflective of the variety of agricultural practices as well as the manufacturing practices and the way people use them. While it could be one product, but in different communities, these can be different and used in a different way. So when we talk about targeting a product for regulation, at least from our perspective in tobacco, what are the kind of things we look at typically? First, we look at the toxicants in the ingredients, and this would include the tobacco leaves, the flavorings, the additives, and other contents that I will be elaborating on. In addition, we look about the toxicants in emissions, and this even applies to smokeless tobacco. Obviously, another factor we look in regulation is the addictiveness of the product, and typically here we're targeting nicotine and how this nicotine becomes available to the user, and the attractiveness of the product and the design features of the product. When we look at smokeless tobacco, they have a large number of chemicals, estimated to be around 4,000, and many of these are proven to be toxicants as well as carcinogens. Now, how these toxicants accumulate, and as you see in this chart, it is a process of accumulation toxins with a variety of sources. Some of it all the way to the left on this chart, they are related to the tobacco leaf themselves, which contain alkaloids such as the tobacco-specific nitrosamines that have been alluded to. In addition, the soil itself contributes to some of the toxicants. Examples of it are the metals, the heavy metals that I'll be talking about later on. And in addition, the nitrates and the conversion to nitrites. There's the preparation of the tobacco itself, And fire curing is the most notorious because, again, here with the fire, you're adding more hydrocarbons, and this would include to increase to the level of the polycyclic aromatic hydrocarbons as well as some aldehydes. And if you move down the screen a little bit to the right, and then the fermentation process, there are bacteria, and when bacteria flourish, they will contribute to the production of nitrosamines, and in addition, they will enhance the formation of TSNA, the tobacco-specific nitrosamine. In addition, there are the microbially derived toxins. Most notorious of these are those which are derived from fungi, the aflatoxins, and the endotoxins which are produced by bacteria. This is also complicated by the fact that there are additives that are routinely added to the processing and the manufacturing of these products. They come in a variety of forms. There are the alkaline substances, and there are also the areca nuts, the tonka beans, the cod. So all these, as you can see, it's a very complex picture, and trying to regulate it in a clear, straightforward way can be quite challenging. But just to give you a reflection of the challenge we have in regulating these products. So in regulating these tobacco products, obviously the larger the number of these that you would like to regulate, the task becomes more difficult and complicated. So in the work of the Tobacco Product Regulation Scientific Group, the focus has been trying to identify a reduced number of compounds that can balance these concerns and try to be somewhat realistic in implementing it for regulatory purposes.
Dr. Zaatari, may I interrupt you for a minute? Your voice is coming very weak. Will you speak close to the mic?
Sorry, repeat.
Your voice is coming very weak. So could you speak close to the mic?
I'm talking through the mic, but are you hearing me better now?
Yeah,
this is better, sir.
Okay, I'll hold it like this.
Please continue. Thank you.
Can you hear me well now?
Sir, we can hear you.
So the effort of TOBREG was to use some indices to allow the stratification of these compounds or chemicals as far as the toxicity. And this is basically we learned from the knowledge we gained from the same studies on cigarette smoke, and this was extrapolated into the smokeless tobacco as well as other tobacco products. So this was based on toxicity indices based on the risk of developing cancer as well as non-cancerous disease, such as pulmonary disease or oral disease. Many of these have been summarized in a number of these publications. For those who are familiar with it, these can be easily downloaded from the Tobacco Free Initiative website on WHO. For those of you who are unfamiliar with it, these are readily available. They can be downloaded for free. It has a lot of the information in this. These are a technical report series. I would recommend it to all those interested in smokeless tobacco as well as other tobacco products. In many of these series, smokeless tobacco has taken a sizable share of our work in the past years and continues to do so. Now, what are the chemicals and toxicants that we feel take a priority in assessing these and regulating these tobacco products? Obviously, naturally, the first on top of the list is the nicotine. There are the tobacco-specific nitrosamines, NNN and NNK. These are abbreviation of these metabolites of these nitrosamines. The polycyclic aromatic hydrocarbon, most notoriously, is the benzoapyrene, but again, there are a list of these that I'll come back to talk about them later on. In addition, there are the heavy metals such as lead, cadmium, chromium, arsenic, and nickel, and the nitrates and nitrites that has been already alluded to by Mark. Just this highlight again, to highlight the point about heavy metals. If you look at this chart, the ones that are of interest to me are on this table are those which are highlighted in yellow. That's the arsenic, the cadmium, the nickel, and the lead. And you can see they are present in these tobacco products to various percentages, but this will give you the dimension of the that quite a few of the heavy metals are present in these tobacco products, and some of them are labeled as carcinogens, not to mention other biological hazards to the user. So, in brief, what are the measures that we can be used to reduce the level of these toxins? One of these is to reduce the use of Nicotiana rustica, which has the highest level of nicotine as well as the nitrosamines, and I'll come back to talk about it. Or use the flue curing or sun curing during manufacturing rather than fire curing. I know there was some reference to air curing. Air curing does give some hydrocarbons, but to a lesser level than those with fire curing, as I will show in the subsequent slide. Pasteurization of the product will try to eliminate the bacteria and microorganisms, and thus will reduce the risk that comes with the fermentation that exists in these products. And the avoidance of storage for a long period of time, especially in warm weather, where quite often the use of these products is widespread. This is here just a slide. I'm not going to dwell too much on it. Mark has nicely showed the wide spectrum of level of nicotine in these variety of products that has been selected from different regions of the world. And you can see still in many of these, there is a high level of nicotine, but obviously the highest are in some products that are seen in Bangladesh as well as in Sudan, where the use of tumbak is quite prevalent. So coming back to the tobacco leaves, the Nicotiana tabacum is the most common type. However, in parts of South Asia, Africa, and the Middle East, as well as South Africa, Nicotiana rustica is used, and this is usually carries a higher level and content of nicotine and the alkaloids and the TSNAs. Nicotiana glauca lacks nicotine but has a very high level of anabasine, which is very toxic. Luckily, this is used in very restricted parts of the world. So from practical work purposes, the other two are more of importance for us for regulatory purposes. So replacing N-rustica with N-tabacum can produce an opportunity to reduce those levels of toxicants. This is here just to show what has been alluded to earlier. This is a histogram showing a number of polycyclic aromatic hydrocarbons, and you can see the bars in red for those which are outcome of fire-cured tobacco, while the orange bars reflect those which is an air-cured tobacco. So in both cases, still there are high levels of these PAHs. However, obviously the level is much higher in fire cured, and that's why fire curing needs to be avoided. Benzoapyrene, which you see all the way to the right of this table, is usually used as a good indicator of the level of these PAHs in these products. And that's why for regulatory purposes, it has been recommended as the chemical to look for in these products for regulatory purposes. So again, bringing you back to a question about the fermentation that I alluded to earlier. This is a study done in 2007, but the point I want to leave with you here, I know this may be sound, but just basically to show the level of microorganisms as documented by culturing. And all the way to the right here, you can see those levels of bacteria that are producing toxins, as well as surviving in aerobic conditions. And even here, even after the lack of survival of these products, you can see the level of aflatoxins or the production of endotoxin will perpetuate even after the survival of these, because these are put out by these products. So the presence of microorganisms, more so of bacteria and less so of fungi, are very key factors in the production and the precipitation of toxins in these tobacco products. And here, as you can tell from this table, that if you leave these even with under high temperatures, high humidity, extended storage, all these would increase the level of TSNAs. And obviously, the longer the period is, the greater the amount of these toxicants will be detected in these products. This is basically a table to show the relationship between the fermentation and in addition to the fact that the presence of nitrate that can be also sourced from the soil. In addition, the bacteria can also act on some of them to convert them into nitrite, adding to the toxicity of these products. So here the chart trying to show that with storage, there is an increase in the level of these bacteria. There's increased level of these nitrites as well as TSNAs with the longer duration of storage. So a measure that can be implemented for regulatory purpose is to impose a production and product standards. And these need to be reinforced and apply uniform standards for transnational products. So this way there can be some global uniformity of these products, especially for these multinational manufacturers who sell their products in many regions of the world. And in addition to these, obviously to reduce the appeal and addictiveness of these products. And I'll come back to talk about the flavorings and their effect on making these products very attractive to the consumers. The study group on tobacco product regulation, in its technical report series 955, it has mandated the upper level of toxicants in smokeless tobacco to the following. For the nitrosamines, specifically for NNN and NNK, to be 2 micrograms per gram of dry weight tobacco. And for the benzoapygreen, not to exceed 5 nanogram per gram of dry weight of the tobacco. But at the same time, emphasizing the fact that these only should serve as a guideline. There is never a safe level of a toxin, but at least in trying to bring down those levels that we see in this wide variety of products and the great variation in the level of these toxicants in these products. And basically, these were based on a survey of all the products that are available worldwide, and the fact that the industry is capable of bringing down the level to very low levels of these toxicants, as has been documented by the work that has been done by in the Scandinavias, which has implemented the Gothiatic standard. And this is basically the standards by the Swedish match, which was already introduced almost like 20 years ago, and shows the maximum allowable concentration of select SLT chemicals. I apologize for those of you who cannot read this, but this would be made available to you. And again, this information is also available on websites where you can get this information and this concentration. But the bottom line is trying to reduce these chemicals to the extent possible in order to reduce the risk of some of these products and reduce the effect of these products which have a very, very high levels of toxicants. Coming back to the additives, and these are typically added to the products for 2 purposes. The first purpose is to potentiate the nicotine effect. Mark nicely talked about the alkaline agents that are added to these products, because this will increase the level of the free nicotine, which is the form of nicotine that will give the satisfaction to the user. Or in addition to enhance the attractiveness of the product itself. And these come in a variety of sweeteners, humectants, salts, flavorants, etc., mentholated products. All these will serve the purpose of being more attractive, especially to a novice user. The mean pH is quite variable. That's not surprising to you, and again, depends on the product itself and the satisfaction of the user, who quite often they can manipulate these added compounds in order to, especially alkaline compounds, in order to satisfy their needs. And as you would imagine, these alkaline compounds are facilitating the availability or increasing the level of these free nicotine that is thereafter. So attractiveness is a major item in this regulatory affair. And this basically, when these are basically trying to target the taste, the smell, and the sensory attributes of a product, make it the ease and convenience of use, the cost, the reputation or image, and obviously the promotion. These are products with reduced harm, but obviously there is risk of their use as already presented. And again, other characteristics of a product that are specifically designed to initiate the use of these products. I know it's hard to talk about smokeless tobacco, especially in regions of the world where the use is quite prevalent, and ignoring a discussion on the areca nut. This is part and parcel of the product in so many regions. And in some situations, while it can be used with tobacco, but frequently it is an additive to the tobacco products. And this, again, another alkaloid, and there is also an active ingredient, which is carcinogens, the ericolinine and other tannins. So there is a monograph that has been put out by IRC on this, indicating that betel quid with tobacco is carcinogen, and betel quid without tobacco is also carcinogen. And that's why in addressing smokeless tobacco, particularly in parts of the world and regions where the use is quite prevalent. We cannot ignore the discussion on smokeless tobacco without making reference to the areca nut. TCRB also have issued an advisory on the use of mentholated compounds, which usually are used to reduce the harshness of tobacco. And basically the recommendation here is to ban menthol in all tobacco products. For those of you who are unfamiliar with this advisory note, again, this is available on the website of TCRB or the Tobacco Free Initiative. And I would urge those of you to become familiar with its contents, because it is pretty comprehensive and not restricted only to cigarettes or combusted tobacco products. Now, by now, you have an idea about what are the chemicals that we are trying to regulate. We have the metals, we have the nicotine itself, the polycyclic aromatic hydrocarbons represented by benzoapyrene. We have the tobacco-specific nitrosamines, nitrites, and nitrates. These are the compounds that has been the primary focus in our work in collaboration with the Tobacco Laboratory Network in trying to come up with a means to do the assay. Already, the Tobacco Laboratory Network has issued some standard operating procedures for the testing of these chemicals in smoked tobacco products, specifically in cigarettes. And there has been the short-term strategy is to adopt. Sorry. So there's this attempt at adapting these SOPs to the smokeless tobacco. And are you having a problem hearing me? So there's this attempt at adapting these SOPs to the measurement of these toxicants in smokeless tobacco, and also how these can be used and implemented in the short term and mid-range, and then setting up an inventory for these products as well as the analysis, but then ultimately to recruit more labs to join this network in order to verify and validate the testing for these products. And I think India has taken a good lead in trying to do this work. Singapore, as well as others, in trying to do some testing for smokeless tobacco, and this effort should be encouraged and supported. So in brief, basically looking at these SOPs, this is a difficult table, but if you look at it and spend a few minutes on it, it's easier than what it looks to you. Because if you look all the way to the left, for the products, we're talking about the toxicity for the nitrosamines and for the benzoapyrene. The methodology is already established. It is well published. Also, measurements in the heavy metals, that can be also done. If we look about the addictiveness, talking about nicotine and ammonia, these can also, the standard operating procedure can be applied for this purpose. And finally, when you look about sugars and humectants that can be added to the products, these are also can be measured by established methodology. So today we have the means to do the testing and to promote the work. Some of these regulatory labs that are joining the Tobacco Laboratory Network. So the effort is going in the right direction, at least for the time being. So tobacco product regulation is a challenging topic. As you can see, this figure or this picture illustrates that it's a bumpy road. There are the ups and downs, but obviously we should remain focused on the objective of trying to bring these products into some regulatory framework. The industry so far has been evading this, but I think our duty now is to bring it more and more into focus, into trying to get into the agenda of the WHO and the Knowledge Hub on smokeless tobacco. Now, what are these control policies? There should be a comprehensive tobacco control programs, including monitoring and legislative prevention measures. Second, education and awareness efforts on dangers of tobacco use, including SLT. The Knowledge Hub on smokeless tobacco has taken a lead on this, and I would advise all of the listeners here to become familiar with its work. And the recent monograph it has published also on some of regulation and the implementation of FCTC articles. There's also the control, how to manage the cultural acceptance of these products. Banning on advertising, promotion, sponsorship, the so-called tabs. raising taxation, subjecting these products to the same regulatory taxation schemes like other tobacco products, and to ensure that cessation programs are inclusive of smokeless tobacco. There is an need for greater collaboration between different bodies, also securing administrative funding for control, validation of testing method. This is crucial for the work and completion of work by TOBLABNet. And there has to be somewhat universally agreed upon reporting format in order to exchange information and make sure that we have an appropriate global data repository that can be used for a regulatory purpose, as well as education, as well as control. And typical of industry, it tried to engage us into legal challenges, so we have to be prepared for this. And as Mark nicely put it out, there are always these novel tobacco products that we should keep a watchful eye on them. So in conclusion, try to reduce the use of Nicotiana rustica, require that tobacco be sun or flea cured rather than fire or air cured, limit bacterial contamination, which can promote nitrization and carcinogen formation, pasteurization to kill bacteria, improve storage conditions such as refrigerating of the compounds before sale, affix a date of manufacture on these products, banning flavoring for countries who are willing to take this bold decision, set manufacturing standards and mandating upper limits of TSNA and benzoapyrene. Also, see if we can set limits for free nicotine and pH. The two go hand in hand. And then also eliminate ingredients such as the areca nut and tonka beans, which are known to be carcinogenic. And also soil and dirt in the processing, which can reduce, this way would reduce microbes and metals, and the avoid of use of some of these fertilizers that will go to contain heavy metals that will ultimately increase the toxicity of these products. So it is a rough road we have ahead of us, and obviously we have to keep in mind we can sit here and talk about regulations, but ultimately to reach to some of these, like this lady selling out smokeless tobacco on the streets of Bangladesh and in many parts of Southeast Asia, as well as in Africa and other countries. Thank you very much. This brings it to conclusion, and I'll be happy to take questions.
Thank you, Ghazi. That was very succinct and very appropriate presentation. We have time for a few questions for Dr. Ghazi and Dr. Mark. So kindly write your question on chat, or else you could speak after raising your hand.
Yes, Dr. Sujan.
Thank you, sir, for this wonderful presentation. I was just curious about the tonka beans, which you mentioned about in the last slide. Can you please elaborate on that a little bit?
Your question is to whom?
Dr. Ghazi.
Dr. Ghazi, there's a question about tonka beans.
Tonka beans.
I'm hearing about that for the first time, so I'm really curious to know about that.
Yeah, tonka beans, they contain some very strong carcinogens, and some of them will contain coumarin, and coumarin is also something that will enhance bleeding. So that's why it is used primarily in Latin America, so and less so in Africa and Southeast Asia. So that's why the banning on these, because they enhance toxicity of these products.
Thank you, sir.
Thank you, Ghazi.
Any other questions?
Well, and I was just going to add, I did see a couple of questions come through on the discussion board. And one question which I thought was good, which was worth mentioning, is someone had asked me about if there are different approaches to cessation, to tobacco use cessation for these different products. And basically my response was that, we don't really have the evidence yet to show, to recommend a particular protocol for cessation for a particular product. We just sort of have a general recommendations for tobacco cessation counseling and for medication for, for tobacco use in general. there is a somewhat different approach for smokeless tobacco versus smoking, in that we know that some of the pharmacologic interventions that work in smokers are not as effective in smokeless tobacco users. But the recommendations around counseling and that are very similar. However, I think, you know, there is a need for more sort of research into how do we tailor the counseling interventions to a particular cultural context and setting. And so that's an area we need to do more work in.
I agree with Mark, and that's really a challenging thing. We need to learn and see which efforts. And I think the key fact in any of these cessation programs, especially in areas where the use is quite prevalent, is to address the cultural aspect in addition to there's likely the community in addition to the individual, because these two go hand in hand. This applies not only to smokeless tobacco, it applies to water pipe use as well as many other forms of tobacco.
I would add to that, smokeless tobacco, water pipe, these are all different beasts, but looking at the culturally appropriate circumstances and the background of the individual cannot be overemphasized. Thank you so much, Ghazi and Ma. If there are no more questions, maybe we can call it a wrap.
Okay, thank you very much, and I'll be sending you the presentation in case you want to upload it on your website.
Sorry to interrupt, Dr. Ghazi, we have a question.
Yeah.
Somebody is just asking for seeking clarification on the role of methanol on toxicity.
On what?
Role of menthol on toxicity.
Sorry, I'm missing. What toxicity?
Role of menthol on toxicity.
Menthol?
Yes.
No, you see, there has been several studies on the menthol use. First of all, it enhanced the effect of the nicotine, and in addition, there has been some animal as well as studies to show that indeed it has this toxic effect. In addition to by the enhancing the effect of some of the chemicals that are present within tobacco products. So these mentholated products will ultimately lead to this to exaggerate the effect of the toxicity of these products, and that's why menthol has been recommended to be banned from these products. And for more details, I would have loved to expand on it a little bit more, but I will urge the person who's asking the question to visit the website and download. It has detailed information. Actually, we're coming up even with a follow-up report from a technical report on the flavoring in tobacco products. Very soon, group. So please, I urge the person who asked the question to visit, and there's a concise summary at the end of the advisory on the information that could be pertinent to help this person in addressing this question.
Please stop sharing. Dr. Ghazi, may I request you to please stop sharing your screen?
Can you repeat, please?
If you could stop sharing your screen, we are still looking at your screen on
the presentation.
I'm sorry, I'm not hearing you well.
Actually, just send by chat. Don't worry, I'll do that.
We request Professor Mehrotra to sum up and close the session.
Okay, thank you, Amit and Chandan and Anshika. It has been a very enlightening talk, and I've really enjoyed both the presentations by Mark and Ghazi. They were very practical tips, and they have both promised to share their presentations with the participants, as well as share any links. I was really interested in sharing the top reg as well as the top left net links to the website, so that anybody has any queries, we'll go on further and look at it. At the same time, I would also request the participants to email any questions that they may have for the speakers in case something is still lingering. I'm sure the hub will be able to arrange for the answers to them, and also to handhold any queries as well as any problems that we can come across. So with those words, let me thank both the speakers. They've done a commendable job, as well as all the participants who've stuck it through. I'm sure we are enlightened, and we are looking forward to more such talks in the future. Thank you, one and all.
Thank you.
Thank you, everyone.
Thank you. Dr. Zaatari left. Mark said left. And Shivani left. रिकॉर्ड हो रहा है